Regular expressions are the algebraic counterpart to finite automata, and they can be manipulated by certain algebraic laws. And these algebraic laws we'll have a closer look at in this video. The first law is commutativity that we all know from basic algebra. We know that 4 plus 5 equals 5 plus 4. And the same thing holds for regular expressions. If we have two regular expressions, e plus f, they define the same language as the expression f plus e that's expressed here. The equality is to be understood to mean language equality. If we have a look at an example, the language a star b plus b star a, so the set of all words that start with a's and end with a b, or start with b's and end with one a, is the same as the set of languages that start with a b and end with an a, or start with an a and end with a b. The same works, of course, inside parentheses. So the language a star followed by b star plus c star is the set of all words that start with an arbitrary number of a's followed by an arbitrary number of b's or an arbitrary number of c's. And this is, of course, the same as having an arbitrary number of a's followed by an arbitrary number of c's or an arbitrary number of b's. So here we have commutativity for regular expressions. It actually stems from the commutativity of the union operation for sets. The second law is associativity. That's also known from the natural numbers. The parentheses can be omitted. For example, if we have 4 plus in parentheses 5 plus 6, it's the same as 4 plus 5 parentheses plus 6. And for a regular expression, we have the same. If we have the language a star b plus b star a plus c star a, the parentheses don't matter, and we can put them around b star a plus c star a, or around the first terms a star b plus b star a. The same is true for concatenation. Concatenation is also associative. It's of course not commutative. Yes. And the last algebraic law on this slide is distributivity. That's also known from the natural numbers. 4 times 5 plus 6 can be written as 4 times 5 plus 4 times 6. And we have the same for the regular expressions. The language defined by a star, b star plus c star is the language of all words that start with an arbitrary number of a's followed by either an arbitrary number of b's or an arbitrary number of c's. And of course, the same language is expressed by saying, okay, at first we have an arbitrary number of a's followed by an arbitrary number of b's, or we have an arbitrary number of a's plus an arbitrary number of c's. And that works from the left and from the right. So as concatenation is not commutative, we have the distributivity law from the right hand and from the left hand side. Adding 0 or multiplying by 1 doesn't change anything for the natural numbers. And it's the same for regular expressions and regular languages. If we take the union with the empty set, it doesn't change anything, because if we have a regular expression e and we take the union with the empty set, we just take all the elements from the empty set and add them to the set defined by e, and of course that doesn't change anything. So we have the rule that the empty set plus e equals still e. And the same is true for concatenating with the empty word. If we take all the words from a language and concatenate the empty word to the left or to the right, the words do not change. So we obtain the rule that concatenating epsilon, the empty word, from the left or from the right doesn't change anything. If we have a look at these examples, it's taking a star b, set of all words starting with an arbitrary number of a followed by b, or a word from the empty set. There's no word in the empty set, so doesn't change, so we still have all the words starting with A's and ending with one B. Same for adding the empty word. If we have all the words starting with a B and ending with a B, and there are not only A's in between, then adding the empty word to all these words, the words do not change. So the expression to the left and to the right, they define the same languages. From the natural numbers, we know that multiplying a natural number by 0 results in 0. So 4 times 0 is 0. And the same is true for the regular languages and regular expressions. If we have a regular expression E and we concatenate the empty set from the left or from the right, we obtain the empty set, because this actually means we take all the words where the first part is in the empty set and the second part is defined by the regular expression E. As there are no words in the empty set, there is no word that would satisfy this condition, that the first part is in the empty set and the second part is in E. So the result is actually the empty set. The same here for the languages. If we have an expression A star B concatenated with the empty set, that's actually all the words that start with an arbitrary number of A's followed by an arbitrary number of B's followed by something from the empty set. But as there's nothing inside the empty set, the result is, in the end, the empty set. So the empty set is similar to the 0 for multiplication. Finally, let's have a look at some rules involving the Kleene star. If we have a regular expression like A star and we apply the star again, nothing really changes, because A star is an arbitrary number of A's. And if we take an arbitrary number of A's and we take an arbitrary amount of words, each comprised of an arbitrary number of A's, then it's just an arbitrary number of A's. So actually, if we have two stars, E star, and the expression is start again, then this is the same language as E star. If we star the empty set, the result is actually the set that contains epsilon. So the expression empty set star is equal to epsilon. And if we star an arbitrary amount of epsilons, then the result is of course epsilon, because if we put, for example, 3 epsilons together, it's just still the empty word, no matter how many times we concatenate the empty word, nothing changes. Usually you don't not only have the Kleene star, but also the Kleene plus, which is defined just as the concatenation of E with E star. So in E star, we always have the empty word, the epsilon. If we don't want the epsilon, we can instead just use the plus, Kleene plus, and then we get the set of all concatenations of words from the language without the epsilon. If we look at this example, AB star is epsilon, AB, 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 and so on. And compared to the language defined by AB plus, it starts with AB, so there's no epsilon inside, and that's the difference. So these were the algebraic laws, and they can be used to manipulate algebraically the regular expressions.